Good morning, students. Now we'll explain the questions in the quiz. Okay. So the question was a two-story column ABC in a building AB equal to BC equal to 2.8 meter is constructed with hollow square box section. The outside dimensions are 200 millimeter by 200 millimeter and thickness is 15 millimeter. The roof load at the top of the column is P1 equal to 400 kilonewton and the floor load at the mid height is P2 equal to 500 kilonewton. Okay, so this is the roof load P1 and this is the floor load P2. Obtain the compressive stresses in the two parts of the column due to these loads and also calculate the shortening of the column. Modulus of elasticity of the material of the column is 203 gigapascal. So this is the cross section. So first we'll find out what is the cross sectional area. So what is the cross sectional area? Cross sectional area is equal to capital A, which is equal to 200 square minus 170 square, which is equal to 11100 millimeter square. E is given as 203 gigapascal, which is equal to 203 into 10 raised to 9 by 10 raised to 6. So this is equal to 2.03 into 10 raised to 5 Newton per millimeter square. Okay. Now we have to consider first portion BC. Portion BC, the axial force is equal to in portion BC, the axial force is equal to P, which is equal to P1, which is equal to 400 kilonewton. So what is the stress? Stress is equal to sigma, which is equal to P1 by A. A is same for both the sections. So what is area? Area of cross section 11100 millimeter square, because this is a hollow rectangular section. So stress is equal to 400 into 10 raised to 3 divided by 1100 millimeter square, which is equal to 36.036 Newton per millimeter square. Okay. Now we can find out this is a compressive force, so there will be shortening of the length. Columns are subjected to compressive loads which will lead to the shortening of the columns. So delta L1 is equal to stress by Young's modulus, 36.036 divided by 2.03 into 10 raised to 5 into length. Length of the section, bottom section is 2.8 meter. So this is equal to 0.492 millimeter. Okay. Now we have to consider portion AB. Here the axial force is equal to P, which is equal to sum of the loads P1 plus P2, which is equal to 900 kilonewton. So we can write stress is equal to 900 into 10 raised to 3 divided by 11100, which is equal to 81.081 Newton per millimeter square. So what is the total shortening? Shortening is equal to, shortening is delta L2 is equal to stress 81.081 divided by modulus of elasticity 2.03 into 10 raised to 5 into length 2800, which is equal to 1.107 millimeter. Now what is the total shortening? Total shortening is delta L1 plus delta L2. Delta L equal to delta L1 plus delta L2, which is equal to 0.492 plus 1.107, which is equal to 1.6 millimeter. Okay. Okay, now I will discuss the question. A steel cable of diameter 5 mm and length 10 meter hangs freely. Find the maximum stress induced in the cable. Unit weight of steel is 7,850 kilogram per meter cube. Also find the extension of the cable. So unit weight means gamma is given. Gamma is 7850 kilogram per meter cube. Now since the dimensions and gamma is given, we can find out the self weight of the cable. What is the self weight of the cable? Self